Well, welcome everyone. This is the season finale of our Out to Lunch series, and we're very excited to have a presentation on the August eclipse. Out to Lunch was organized by the ESIP Education Committee, and it's hosted by the Earth Science Information Partners, which is a national organization with over 120 members collaborating to advance the use of Earth science data across society. My name is Margaret Mooney, and I'm talking to you from Madison, Wisconsin at the Cooperative Institute for Meteorological Satellite Studies. And I'm honored to introduce Dr. Patricia Reiff from Rice University, and she's going to present on the solar eclipse 2017. Thanks, Pat.
All right. Well, I can make this in 1 hour talk, and making it 10 minutes is tough, so I'm going to go quickly. So the idea is, where do we go? How do we observe safely? Because that's one thing you want to know is where to go and how to see it. So everybody in the continental United States will be able to see at least a partial solar eclipse. Most will see 50% or more. And we are the only country that is in totality for this event. So this is the strip of totality where you want to be. There's a really nice Google map that you can click on, and it'll give you the exact circumstances and drill down into your very nice location. But you want to be in that stripe. But you also see here's 90%, 75%, 50%. So everybody in the United States will see at least a 50% coverage. And here's where you see that it's only the U.S. is in the zone of totality, because here it starts at sunrise and there it ends at sunset. So what is a solar eclipse? Well, a solar eclipse is the moon casting its shadow on the Earth, whereas a lunar eclipse is the Earth casting its shadow on the moon. Totality means that the exact alignment is that the entire sun will be covered by the moon, allowing us to see the corona. So here's kind of a diagram of how it looks. The sun is big and far away, the moon is small and close, but they are the same angular size. And if you are in this small region called the Umbra, then you'll see a total eclipse. If you're in the penumbra, these gray areas, then you'll just see a partial eclipse. A lunar eclipse, on the other hand, is much more common because the Earth's shadow is larger. Okay, so I have a nice animation, and there's some great animations that you can get from my website.
When the new moon passes exactly in front of the sun, its shadow crosses the Earth. The deepest part of the shadow is called the Umbra. People in the Umbra see a total solar eclipse. It takes about an hour for the shadow to cross the Earth. 2 weeks later, the full moon can cross into Earth's Umbra. Since the Earth is 4 times the diameter of the moon, the Umbra is also 4 times larger, or 16 times the area. So, lunar eclipses are more common than solar eclipses. Everyone on the night side of Earth can see a total lunar eclipse, but only people in the narrow strip of totality can see a total solar eclipse. So, not only are lunar eclipses more common, more people can observe each one.
Okay, so the phases of the eclipse, the first contact is when the moon starts to cover the sun. Second contact is the beginning of totality. The diamond ring is just before that. Third contact is the end of totality, and the fourth contact is the end of the partial. So again, here's a video. Oops, and again, you can watch all of the videos on my website.
First contact is when the disk of the moon first starts to cover the sun. During the partial phases, you must use solar filters or projection techniques to safely observe the sun. It takes about an hour for the moon to completely cover the sun. The last bit of the sun is the diamond ring. Second contact, totality. Third contact, put back on your filters. The last.
Okay, so I'm going to skip some of these. So here's what you'll see during totality. You'll see the wispy corona These plumes show you the direction of the magnetic field at the surface of the sun. So the sun has loops of magnetic fields near the surface, and some of these will be bright red from trapped hydrogen atoms emitting in hydrogen alpha light. But you won't see that kind of a view in your photographs. You have to assemble several photographs to get that. But it does look like that to your naked eye. So let me just show you what the Bailey speeds will look like.
As the moon covers the last bit of the sun, the sky around you gets dark. It's still not safe to remove your solar filters, though. The last piece of the sun makes a diamond ring. Bailey speeds appear, small bits of the sun peeking through valleys on the edge of the moon. Now it's safe.
Okay, so the moon's shadow is not a sharp spot, but it has some fuzziness because part of that is umbra and part of it is penumbra. And I have more animations of what you might see from the lunar surface, and I'm also not going to talk about lunar eclipses here because I don't have time. But I do have one that I want you to see, which is an animation of a lunar eclipse as seen from the moon. So when it's a lunar eclipse as seen from the moon, it's a solar eclipse for them.
In a lunar eclipse, the moon travels through the Earth's shadow. If you were on the moon, it would be a total solar eclipse for you. But the Earth appears 4 times as big as the sun. The land around you gets dark. When you are completely in Earth's shadow, the land around you is red. The only light that reaches you is red light bent by Earth's atmosphere.
Okay, so if the moon happens to be too far away to cover the sun, you get an annular eclipse. The moon tries to cover it up, but there's still some sun around the edges. And that's one I saw from Sandia Peak that we had a few years ago. So where do I need to go? Well, you need to go to Totality. If you can, expect heavy traffic. Don't drive when the sun is more than 50% covered. There are still places that are reasonably inexpensive if you drive about an hour away. So here's this interactive map that you can zoom in, and it'll show you the times of the first contact and maximum totality. And you can get to that through my website. Okay, so why do I need to go to Totality? Well, it's a multi-sensory experience. It's not just your eyes. The temperature drops, the wind picks up, the birds roost, you know, the shadows become very strange and sharp. You see little tiny eclipses in the leaves, and so these are the kinds of things that make it a very whole body experience. And that anticipation of totality, it just gives you the adrenaline rush. Some of the prettiest pictures are the diamond ring, which is the last thing before totality hits. So we can certainly monitor eclipses from space, and then often you get from space a nice view of something that has been observed from the ground. So as far as science goes, it's not as critical to do eclipses as it once was, but it's still a very beautiful and exciting thing that gets us all excited. So here are some of my favorite fisheyes. You can see the eclipse as being a ring of sunset all around you. One thing, if there is clouds, don't panic. Clouds do have a tendency to thin out during totality, and sometimes you can still see through them. So observing safely, you must protect your eyes during the partial phases, and for most of us, that's every place in the United States. So you can use various kinds of solar filters on your cameras. There's a really nice eclipse write-up that you can download from the NASA site. This is the simplest thing, a pinhole projection. You punch a hole in a cardboard box and you get an image inside, but you can punch a slightly bigger hole and get a brighter image if you focus it with a pair of readers. And so I just took a cheap pair of 2X readers and made a little lens for it. So another fun thing to do is to take a piece of cardboard and punch something through it and take a picture of the shadow. Now you see all the little shadows are little bitty eclipses. Solar eclipse shades are easy and cheap, but they have no magnification. Ideally, you want to put some solar filters on some binoculars, but once you put the solar filters on the binoculars, it's hard to find the sun. So tip your head back, look, face the sun face on with your face. You can tell by how warm it is, and then bring the binoculars up, and the sun should be near the field of view. Always zoom it out to find it, and then zoom it in. It's much easier to put it on a tripod so you can share the experience. You need a tripod binocular adapter, which is this piece right there, that allows you to put binoculars onto a tripod. I like these solar filters from Rainbow Symphony. You can slide them on to your binoculars or to your camera lenses, and they pop off easily for Totality. Here's this binocular tripod adapter. It's not expensive. So you can also do binocular projection because the sun is going to be nearly high in the sky. You can take a binoculars with that tripod adapter and set them up. You make the shadow of the binoculars small, and then you can get the image of the sun. But then, you know, you need to put it into a shadowed area, or you can just take a drape and drape around your binoculars, and that'll make you a shadow to see the eclipse. So everybody should have their own binoculars for Totality because it's only 2 minutes, don't share. Another easy way is a sun spotter. It's not too cheap, but they are available for about $400, and they're extremely safe. Even kids can keep it aligned, which is nice. And they're good even if the sun is almost straight overhead. So this is a hydrogen alpha telescope, which is a lot more expensive, but it allows you to preview prominences. So always good to get some practice on the sun ahead of time so you know how to do it safely. And when's the next one? Well, the next one will be 2024. So here's the one we have now in 2017. Here is 2024. So if you missed this one, you got another one in 7 years. Now there's going to be an annular in 2023 that's also going to go through the United States. And annulars are fun, but they're just not the same. I've been to 13 totalities and 2 annulars. Okay, photography, again, I have some write-ups on my website, but be sure you practice with the full moon. And similarly, videography, you really want to be able to adjust the iris and adjust the exposure and to make it manually focus so it doesn't keep hunting to try the focus. So that's true on cameras or videos. So ultimately what I want to say is enjoy it rather than try to take pictures, because somebody else will take better pictures than you are. So you know, enjoy it, get the most out of it, and here's my website and the NASA site. And if you want to join my Eclipse news list, I send out information and links for free free eclipse glasses for people on my news list. Okay, so that's my 10 minutes, and I'll be happy to answer any questions.
Thanks, Pat. That was great. It's very exciting. I see one question in the chat box, and yes, this is all being recorded, and it will be archived.
Also, if you go to this space.rice.edu/eclipse, there's a PDF of it. And if you want to show it yourself and edit it yourself, you can contact me and I can give you the full PowerPoint version. So we want to make sure that all the eclipse safety is maintained. But there's also a 2-page eclipse safety briefing also on this space.rice.edu/eclipse site. But if you haven't done it, it's awesome. I've been to, as I said, I've been to 13 totals and 2 annulars, and I've only been rained out once. One time the clouds are really pretty bad, but most of the rest of the time I've had a good view. Sometimes the clouds are a little, you know, in the way, and so you make sure really. One more thing to add, bring the excitement is, are we going to see this or not?
All right. Well, if there aren't any questions, I've unmuted everybody, so if you unmute yourself, you can ask, but we're checking the chat box too. So thanks, Pat, for presenting, and thanks everyone for tuning in. We do have this page on the ESIP Wiki with all the talks, all the Out2Lunch talks that have been recorded, and Pat's presentation will be online this afternoon.